with these problems from the indefinite integration homework that are the trig ones. Some of them are done similarly to the ones that are done in the video, and some of them are done a little bit differently. And so I'll try to walk you through how you know when they are similar to that one and when they're different and kind of how to go through them. So the first thing you should look at is all of these integration formulas for the trig functions, because that's where we're looking to see whether or not what we have here is one of the basic integration rules or not. So for example, this one, if you notice that the main function in this one is secant squared. So the fact that secant squared is one of our main integral rules means that I can just do like a more basic or like a simple u substitution to allow us to do that. The only thing that doesn't match it is the 8x. Other than that, the secant squared of x is a perfect match. So that's why I just made the u equal to the 8x and not the whole thing. So that if I did du, that would be 8 dx, move the 8 over to the other side, so I have 1/8 du equals dx. I already brought the 1/3 out front because it's a constant multiple, and I can also bring that 1/8 out front since it's also a constant multiple. My 8x gets replaced with the u, and then dx just replaces the, du just replaces the dx. From there, I didn't finish the problem, but from there, that's just a basic integral rule. The integral of secant squared is tangent of x, so you would go forward from there. For number 18, this is sine of 4x, cosine of 4x, which is similar to one of the ones we had in the videos. But the difference is that one was secant tangent, and if you look over here, secant tangent is one of our basic integral rules. But on number 18, sine x, cosine x is not one of our basic integral rules. I don't see anywhere here sine of x being multiplied times cosine of x, which means I can't just, make the whole thing be my u substitution. Instead, I have to make one of these things try to equal the derivative of the other one. So if I take sine of 4x, that means that my derivative would be cosine of 4x times 4 because of the chain rule. I don't need that extra 4, so I can move it over to this side. Now this cosine 4x dx matches this cosine 4x dx. So my sine of 4x is replaced with a u. My cosine 4x dx is replaced with du. And then the 1/4 comes out front. And now that's just a basic integral rule. By the way, I could have made my u equal to cosine of 4x if I wanted to. It just would have made it the negative, and then it would have fixed it itself in the end. Here, again, cosine cubed sine is not one of my basic integral rules, so I have to find something to make my u so that when I take its derivative is also there. Now, in this case, you cannot choose sine of x to be your u, because the derivative of sine of x is cosine of x, but that would be like having this be your dx and it's cubed, so that doesn't really make sense. So technically, this is like my inside function. If I rewrite this as cosine of x quantity cubed, that's like my inside function. So that's how I know to choose that to be my inside. Derivative of that is negative sine, bring the negative over, and then we do all of our substitutions. You're left with u cubed and that negative out front. On this one, again, looking for something that is one of our basic integral rules, and notice that we have here secant squared, and that matches this secant squared. So I'm going to try to get that to be my derivative, and the derivative of tangent is secant squared. So I made my u equal to tangent. The derivative of that is secant squared. Everything got substituted nice and neatly, so my integral is just u. On this one, my inside function is cosine of 6x. Derivative is negative sine of 6x times 6 because of the chain rule. Bring the 6 over and the negative over. We don't need those. So negative 1/6 is a constant multiple. It comes out front. My cosine of 6x is replaced with u, and then sine of 6x dx is my du. So that gets there. And last but not least, my inside is 4 minus cosine of x. Derivative, because of the 4 is a constant, its derivative is 0. The derivative of cosine is negative sine, and since it's already negative, we have a negative sign, which turns into a positive sign. This sine of x dx is going to replace all of that, sine of x dx. So that du comes from there, and then we have 1 over my u cubed, because that was my u. And again, I didn't finish that problem. I'll let you guys finish that one.